Hello everybody, this is Jason, the Kentucky Fried Ham. I'm sure at this point everyone has heard that Elwood Downey, the creator and maintainer of HamClock, the very popular amateur radio tool, has become a silent key. So HamClock was actually initially created to run on an ESP32, an embedded Wi-Fi radio chip. So it was developed in a way such that it could run on a very low-powered microcontroller, which is why there are only a few fixed resolutions. All the assets are compiled at those resolutions rather than being able to generate them dynamically. And because of that, all the calculations and all the connections needed to present all that data are actually running on a server managed by Elwood. That server is going to be shut down in June. Actually, at the time of this recording on February 8th, it looks like some of the services have already stopped working. So in the meantime, there have been quite a few replacements pop up. One replacement is attempting to replicate his server so that the existing HamClock will work when pointed to the new server with no changes. There are other alternatives, including OpenHamClock, which I'm sure you've seen all over the internet at this point. This is by far the most fully fledged, and there are multiple ways that you can actually use this tool. So I thought I would go through 3 ways that you can use this today from easiest to hardest. So the first thing you can do is you can go to OpenHamClock.com. So Chris, the creator of this tool, runs his own server. All the settings for OpenHamClock are stored in local storage on your browser. So all his server is doing is serving up this web page to you and then presenting all the data, but your local settings are local to you. So I'm in incognito mode here so that I can show you a new setup. So basically, you just go to OpenHamClock.com, you fill in your details, whatever you want here, and we're not going to go through the setup per se in this video. There are other videos showing kind of what this can do. So now we've just set up some basic stuff. Of course, there's different map layers you can turn on, and now here we go. So here's OpenHamClock. Fully functional. You have spots, DX cluster here, you have POTA spots, upcoming contests, etc. But it's that easy. That's method number 1 to run OpenHamClock. So you just go to OpenHamClock.com. That was method number 1. Super easy, right? Next, we're actually going to install via Node running on a Raspberry Pi locally. All right, here we are at the command prompt for a fresh Raspberry Pi install. So I just got a new micro SD card, use the Raspberry Pi imager, and put the latest version of Raspberry Pi OS on here, which is based on Debian Trixie. So the first thing we need to do is install Node. The first thing we're going to do is make sure our package repository is updated, so we're getting the latest versions of all of our packages. Then we're going to run this command. And so this will use the package repository to install the currently included version of Node, and we'll hope it's a version that's compatible with HamClock or OpenHamClock. And I'm kind of just glossing over a lot of this. You can just run these commands and this should work, but if you want a more deep dive into this, just let me know. Alright, there we are. We've installed Node. Alright, so we're going to use this to install npm, which is Node Package Manager. This is how we can pull down the dependencies for OpenHamClock or any other Node package. The next thing we need to do is actually get the OpenHamClock code onto our machine. We're going to use get for that. So let's see, this is my home directory. I'm just going to do it here for now. So let's go ahead and say get clone. All right, so this will actually pull the code to our local machine from GitHub. And I'll post the link for this in the description. And it will automatically create a directory in our current directory for this. So now we're going to go into OpenHamClock, and if we take a look, you can see now we have all the code. Now we need to run npm install, and this will actually install all the dependencies that OpenHamClock requires. All right, there we go, we're installed. So now we run npm start. All right, and we're running. So now I'm going to switch over to my browser. If you are running this with the intent of just showing this OpenHamClock on your Pi screen, you can go to the local browser on your Raspberry Pi and go to localhost:3000. That's the port that this will be on. In my case, I don't have a GUI in this Raspberry Pi, so I'm going to go to my web browser on a different PC and access this server. So we'll switch over and we'll be right back. Okay, so now we are on my browser on my normal PC, and we're going to browse to the IP address of that Pi. So 192.168.3.233:3000 in this case. As I said, if you're running this in the browser on the Pi, you just type localhost:3000, or if you're accessing it remotely like I am here, whatever the IP address of your Pi is. And this warning is about the site not being secure. It's because you don't have a certificate installed on the Pi, and in a future video I'll show you how to get around this warning. But for now it's safe to click this. We're not typing any passwords or any sensitive information. So here's the same screen we got previously when we were running it on the OpenHamClock website. So let's just as a test, let's go ahead and do this, and here we go. So we're running this on our Pi, and actually I wanted to check one thing too here. There was here's an option for low memory. Let's see what that does. I want to kind of play with the performance here. I'm running this on my own server on a Intel NUC box and N100, which I would actually recommend as a nice server platform for your ham shack. And again, if you guys are interested in seeing my network setup and what all I'm running and how I'm running it, let me know. But I mean, this seems pretty performant. This is not bad. Okay, cool. So there's option number 2. This is my least favorite because you have to install a whole bunch of stuff on your computer and it just clutters everything up. And managing versions with Node can be difficult. So if this requires an update in the future, it can be kind of a pain. So with option number 3, we're going to go ahead and show you what I think is the best way to do this. All right, we're back over on the Pi. And when we cloned this repository, one thing you'll see here, actually a couple things. So you'll see a Docker file, and you will see a Docker compose. Where is it? Right here, Docker compose. So without getting too deep into the weeds with Docker, a Docker file describes a way to make a Docker image. And a Docker image is essentially a representation of the system that you need. So it has a base OS, it has all the packages you need, it has anything that anyone has set up for the project. So in this case, if we just look at this real quick, so you'll see that, so this is an image on Docker Hub provided by Node.js, and it's a lightweight image. It's based on Alpine Linux. And so we're basically just copying the files from our local directory into the image, and then we're going to build it, and etc. We're installing all the stuff we need. Here we're exposing ports we need for the server to run, etc. So this will actually build an image, and then you have to later run that image. So the Docker compose file that we saw, this is actually a way of specifying a service, since this can be composed of one or more images. So you can have a whole bunch of images running at once. Once they're running, they're called containers, and you can kind of think of them like a virtual machine if you're familiar with using Parallels on Mac or VirtualBox or VMware, any of those things. It's kind of the same idea, but it's much lighter weight because you don't have a virtual machine actually simulates computer hardware where an OS runs on top of, so it can be really slow. In this case, Docker runs lightweight images as containers on top of your existing OS using facilities built into the Linux kernel. So it's incredibly lightweight, really fast, and you can have a whole bunch of containers running without causing really much system load at all. So in this case, we're specifying a service that's going to use the container named OpenHamClock, which was built from our local Docker file, and you can see that here. So build dot. So this will actually build what's in the local directory using that Docker file we saw. We're going to name the container OpenHamClock. We're going to expose the ports that we need to expose, etc., etc. To run this, all we have to do is go docker compose up. And so what this will do, this will look at that Docker compose file, see what images it needs to pull remotely, see what images it needs to build locally, go ahead and do that, and then start them. All right, so we're done. That took about 15 minutes. So win number one, installing Node and NPM, was probably around an hour on this machine. Here we go. You can see the image built and is running. The container is running OpenHamClock. It looks just like it did when we were running it on Node. If we want to, we can actually run this in detached mode. When you do docker compose up, you can pass the -D flag, or like here, we just hit D. Now you're at your terminal just like always, but the HamClock is still running. So I can do docker ps, and so you can see we actually have a container running here. So now if we switch back over to my browser on my other machine, we should be able to access this just like we could before. So meet me back over there. Here we are back on my browser on my main computer. So if we go back to the same IP address we were at before, here we are. Here's my OpenHamClock, and now we just do the same thing as before. So let's go ahead and set our configuration. So let's go with retro. Let's just have a little fun. All right. So here we go. So you can see the performance is really good, just like it was with when running natively in Node. Let's go to satellite. So actually it seems like it might be even a little zippier than it was straight in Node, but anyway, there we go. So now we've run this 3 different ways: by using the OpenHamClock webpage, by installing Node and running it on our computer, and installing it via Docker. The benefit to Docker, like I said, is, it took us 15 minutes versus an hour, and if I don't want this anymore, I can just delete that image and I don't have anything left. Unlike using the Node method, I'll have Node.js and thousands of packages and lots of hard drive space that's kind of tough to get rid of. So there's that. And actually, let me show you a bonus here, bonus tip. So this is Portainer, and I can get into this into a later video. Again, if you guys are interested in seeing servers and networking for the Ham Shack, let me know in the comments. So Portainer is a way to manage what are called stacks, which are Docker services. And so I have a bunch of services running. Portainer makes it really easy. All right, so we're all logged into Portainer here. Here are all my stacks. And if we go to the OpenHamClock stack, the thing I like about this, so I mentioned that we downloaded the OpenHamClock repository from GitHub, and we ran the Docker file and the Docker compose file. The problem is updating. If I want to update, I have to go stop that service. I have to do a git pull to pull the latest version, and then I have to restart the service, which will cause it to rebuild. It's not a big deal, but it's kind of a hassle. So in Portainer here, what I've actually done is I've got this stack set up via GitHub polling. So I just said, hey, look at the GitHub repo for HamClock, which is right here. And then I say poll it every 24 hours. Actually, I want to change this because this is a very, very actively developed project. And I've noticed that there's 2 or 3 pull requests at least being merged a day with features that I want. So now, basically, this will repoll the GitHub repo every 6 hours. If there's a new version, it will automatically download it and redeploy my stack. So now if I actually go to HamClock, Electric Sheep Engineering, which is my domain, but this is running locally at my house. This is not on the public internet. There we go. Ready to go. So there's my satellite view. All right, so anyway, this is running on my server locally through Portainer. So there's a little bonus tip for you, which I would look into installing that if you're going to have more than one container, or even if you're going to have just this one. Like I said, it makes updating really easy. I know there is a pull request up. I don't know if it's been merged or if it's still being worked on to actually make an official Docker Hub release, which would let you just pull a new version directly from Docker Hub, which would all the build stuff we just did that took about 15 minutes, it would just download a new version. Instead of actually having to do that build, it would just pull it directly. So I hope you found that helpful. I just wanted to show you several different ways you can actually use the new OpenHamClock project. It's already very powerful. It's been about a week, a little over a week, and it's come this far, and there's multiple features merged per day. So I wanted to give you some options for different ways you can use it. So I hope you liked this video and found it useful. And until next time, 7-3.